Okay, so day two of solving these rational inequalities algebraically. And if you take a quick scan at the worksheet, there's kind of two different types of problems we're going to look at. So 1 through 6 is similar to yesterday. I did include some cubic functions, so I'm going to work through one of those with you. But otherwise, it's pretty much the same. The only thing different between 1 through 6 from what we did yesterday, besides some of them being cubic, is that it's not, you don't have 0 on one side of your inequality. So we're just going to rectify that as step 1, and then kind of do the same steps that we did yesterday. So we're going to get one side equal to 0. We're going to factor to find those critical points, and then we're going to do test points in between those critical points to find out where my inequality is true and where it's not. And then if you look at the bottom, 7 through 10, now we have fractions. So fractions are going to work a little bit different. And these are easy fractions. So I'm going to work out a couple of these with you. And then tomorrow we're going to look at kind of the nastier fractions. Okay, so let's go ahead and get started. Number 1, I mentioned that the first thing we want to do is make the right-hand side, I want to make that equal to 0. So I'm going to start off by picking a good color, and I'm going to subtract 22x from both sides. So now my inequality reads negative x cubed minus 2x squared plus x plus 2 is greater than 0. Okay, and now, just like yesterday, I want to factor this thing to find my critical points. This is a 4-term polynomial, so I'm going to try and factor by grouping. If you want to factor out a -1 right here, you can. I'm not going to bother, but you could. So I'm going to just split it in half. So from the left, I'm going to take out a negative x squared right here, and that would leave me with x plus 2. Now on the right-hand side, you see I already have x plus 2, so I'll just factor out a 1. So this now factors into negative x squared plus 1 and x plus 2 being greater than, oh, there we go. Okay, so there is my inequality factored. Actually, you know what? I am going to take out the -1 right here because I can go a little bit further. Because this is now x squared minus 1. So it's actually going to go into, now I have the difference of two perfect squares. So now I have an x plus 1 and an x minus 1. Okay, now I'm completely factored. Everything is factored as far as it can possibly go. And I see that I have 3 critical values here. -1, +1, and a -2. Okay, so I'll just make my number line and I'll plot those 3 on here. So let's see, I'd have -2, -1, and a +1. Okay, so let's see, I want this thing, if I kind of look back to this one when I just minus that 22x over, I want everything to be greater than 0. So at these values, remember, I get 0, so none of these values can be included. So -2 will not be part of my solution, nor will -1, nor will +1. Okay, so now let's just go ahead and plug in some numbers in between. And if you have your calculator handy, feel free to use it. We'll just make our lives a little bit faster here. Actually, you know what? I'm going to use this line. And I'm just going to plug in my values as I go. So when I plug in 2, right, +2, I'm going to have -1 times 3 times 1 times 4. So that's going to get me a negative value. And is a negative value greater than 0? No, it's not. Now I need a number in between -1 and 1, so I might as well just plug in 0. So if I go right back to this one, that would be the easiest. And that would give me a +2, which is greater than 0. So this is a yes. So I know I want to include the values in between those two. And now in between -1 and -2, I'm going to have to do -1.5, which is a little bit annoying, but you can use a calculator, or if you kind of go to this factored version, it's not so bad. So let's see, that would be a -1. And I just want positive or negative. So if I plug in -1/2, this term's going to turn negative. This term's going to be negative. This term is going to be positive. So if I do a negative times a negative times a negative, what does that spit out? That's a negative times a positive. So my whole thing is negative. So are negative values greater than 0? No, they are not. So this is a no. And then I'm going to try the same thing with a -3. I'd have -1 times -3 plus 1 would be a negative. -3 minus 1 would be a negative. And -3 plus 2 would be another negative. So that's going to spit out a positive. So yes, the numbers less than -2 worked. Okay, so now I have everything laid out. I'm going to write this in function notation. I'll go all the way back up here. So it looks like I'm going to come in from -infinity just fine. And I'm going to get to -2. At -2, I cannot use that. So I'm going to use the smooth parenthesis. And then I'm going to jump over to -1 to +1. But I cannot include either of those. And that's it. So those are my values that work. So that's kind of how you're going to handle it if you have a cubic function. Just try and split it in half and factor everything. Number 3, I went through and I made sure that they do, because not all 4-term polynomials factor by grouping, but these do. I didn't want to make it too crazy. So I'm going to leave number 3 for you to do. But I also wanted to do number 4, I think, was the other one I wanted. Yeah. Okay, so let's see what happens with 4. So first thing I need to do is I need to get that right-hand side equal to 0. So we're going to minus 5x and we're going to minus 9. So now we've got x squared plus 8x plus, what's that, 16 is less than 0 is what we're looking for now. Okay, I can factor this. I get x plus 4, x plus 4. All right, so I'm only going to get one critical value, which is -4 in this case. And I get it twice, but that's fine. So no, -4 will give me equal to 0, so I cannot have -4. All right, so let's plug in a number for the -4, 0. So if I go right back to this one, plug in, no, it's not. So this side does not work. Less than -4, negative. So 4 is another -1. -1 is positive. Well, there's a reason I wanted to do this particular one with you, and that is because the solution. There are values of this quadratic that are going to just, if you graph it, it's going to look something like that. It's just never going to cross the x-axis, so you don't get any, no part of your function goes negative. Okay. All right, so there's that. And then the other ones, 1 through 6, you should be okay with. Yesterday's. Let's look now down here at these fraction ones. So I'm 9, and not so bad. Tomorrow I'm gonna add values here. So in order to do that, first make it equal to 0. Second thing you're gonna do, anything fact, you're gonna be factored. Okay, I just got like kicked out of my L2. I'm hoping that I didn't lose the first half of this video. I'll be so mad if I have to do it over again. Anyway, let's go ahead and do number 7. So I already mentioned that you're going to factor, but there's nothing to factor here, so we don't have to worry about it. So what you're going to do now is you're going to take each of your factors and set them equal to 0 to find those critical for the numerator and the denominator. So in this case, I'm going to get a critical point. Oh dear. Up top here of -5, and then on the bottom, I'm going to get one of -7. Okay, so those are going to be my values that I go ahead and plot on my number line, -7 and -5. Now, it is still true, it is always true that I'm never allowed to have a 0 in the denominator. Okay, so -7 cannot be part of my solution because it would break everything. So I'm going to go in right now and put an open circle at -7 because that's an impossible value. Okay. Now I can have -5, right? If I plug in a -5, that gets me a 0 in the numerator, which is fine. And then 0 divided by, that would be what, 2? It's just 0. So it doesn't break the fraction just by having a -5. However, if I plug -5 in, is my answer less than 0? No, it's equal to 0. It's not less than. So in this case, I'm going to have an open circle at the -5 as well. Okay. And now I'm just going to, there's my critical points. I'm going to plug in my other values. So I don't know, let's start with something greater than 5. That's just 0. So that would be 5/7, right? If you plugged in 0 to the original, which no, is not less than 0. So these are not going to work this way. No. Now let's plug in -6 in between. So -6 in my numerator would get me a -1. -6 in the denominator would get me a 1. So -1 divided by 1 is -1, which is less than 0. So yes, that works in between those two. And then we'll go ahead and pop in -8. So that would get me on top -3. On the bottom, that would get me a -1. So that's a +3, which is no, not less than 0. Okay, so the only values that work here, I'm not including the -7 or 5, -5, sorry. So it would be just that, those right there. Okay, and now let's try number 9. Okay, so I have one side equals 0. Great. My critical points, I'm going to get a 7 from the numerator, and I'm going to get a 1 from the denominator. All right, and then I ask myself, can I have either of these 2 points themselves? I absolutely cannot have +1 because that would give me a 0 in the denominator, and that breaks everything. Can I have 7? Well, if you plug in 7, the numerator becomes 0, but that's fine. So in this case, I'd have 0. Is 0 greater than or equal to 0? Yes, it is. So 7 is actually a perfectly fine value to have. So I'm going to fill that in with a closed circle as best I can. It's really hard to close circles on this. Okay. You get the point. All right, now let's go ahead and try some of our values. So I'll start all the way over on the left. If I plug in 0, that would get me -7 over -1. which is a positive 7, and positive 7 is greater than or equal to 0, so that's going to be a yes over here. In between 1 and 7, I'll plug in 2, so that would get me a negative 5 over 1. Divide those two, that is a negative. Negatives are not greater than or equal to 0, so that's going to be a no. And then I'll just plug in positive 8. So 8 minus 7 is 1. 8 minus 1 is 7. 1/7 is positive. So this is a yes over here. Okay, and now I'm just going to write that in our interval notation. So I'm coming from negative infinity all the way to positive 1. I cannot include positive 1. Then I'm going to jump over to positive 7. I can include 7, so I want to make sure that I have that square bracket. And then I'm going to go off to positive infinity. And then we have it. Okay, so try the rest on this sheet and we'll get to the really, I don't want to say the interesting ones tomorrow. Okay.